Welcome to another unit in this workbook, Statistics. This time I'm going to talk about the so-called geometric distribution. The geometric distribution could also be called the distribution of the first realization of an event. So it's about, for example, I'm rolling dice and want to know which dice roll I will get my first 6 on a 6-sided dice. If I roll a 20-sided dice, on which roll I will get my first 15. So whenever it's about the first event of a certain kind occurring, then we're going to use the so-called geometric distribution. That's also an important aspect because some people think, well, geometric, that sounds similar to hypergeometric, so it must be the same thing, and then I mix up geometric and binomial distribution. That's not the case. Geometric distribution is about the first occurrence of an event. The probability function here is actually pretty straightforward because the probability of the event happening at time k is just that at the first k minus 1 times it should not happen, and then at the point in time when we're looking for, at point k, it should happen. So we multiply the probability of the event happening in event k with 1 minus pi, so the counter probability of the event happening, not happening for k minus 1 times. So that's actually pretty straightforward. However, that's often not the probability we are going to need here because, well, the event happening at a distinct point in time might be interesting, but more interesting would be something like the event happening before point this and that, or after point this and that. So what we are mostly interested here in this case, even though the geometric distribution is a discrete distribution, is the distribution function. And opposite to most other discrete distributions, we can nicely write this down without the need of any sum sign, because if we want to know what's the probability that an event occurs before or at point k in time, we can simply use the formula 1 minus, and then in parentheses 1 minus pi to the power of k. So in other words, we're going to go with the event did not happen k times, and then we're going to subtract this from 100%, because that's actually the exact opposite of what we're going to do here. So this is the opposite of that. The event happens somewhere between time 1 and k, and this is the event did not happen from point 1 to point k. This is the counter probability thereof. So both the probability and the distribution function are actually pretty straightforward for the geometric distribution. Similar are the two main central statistics, the mean and the standard deviation. In both cases, we can simply use the probability of the event occurring. With the mean, it's simply 1 divided by the event occurring. And for the standard deviation is 1 divided by then probability squared minus 1 divided by probability, or rather minus the mean. Or in other words, we could even say what we have here is nothing else than mean squared minus mean. And well, that's everything there is on the geometric distribution. So I hope you enjoyed this session. I say goodbye and until next time.